Hi, my name is Ryan, and I'm a senior studying in Ho Chi Minh City's University of Technology. I'm glad to be here today to talk about my science research topic. It's called Design a Model for Measuring and Training Muscle Thought of the Hand. And now we're going to figure out this topic. First, the hand is one of the most important human organs, located at the end of the arm. They have the function of grasping, creating precise movement and meeting the creative needs of people. The fingers in a hand contain many of nerve endings in the body, providing the largest localization and the richest tactical feedback in the human body. In addition to the fingers, the hand also has a system of bones, muscle, ligaments, and joints. In that case, we created a model called Model for Measuring and Training Muscle Thought of the Hand. We try to make products suitable for the needs of users, reduce costs, and be more compact, help users have a good experience and stable accuracy. In addition, it also offers reasonable physical therapy solutions for users. Next is introduction. As we know, due to relatively complex structure and the part that performs human activities, the hand is also an easy place for injuries and related disease. When there is a problem in the hand, the manifestation can be pain, weak grip, or even no longer obeying the instructions of the nervous system. The causes of disease or injuries are traffic accidents, labor accidents, daily living habits, etc. Loss of flexibility of the hand. Then we did treatment and rehabilitation exercise to regain the flexibility of the hand. Currently, the world is mainly researching and manufacturing rehabilitation exercise machines and using the experience of the instructor to evaluate the patient's activities. But if only using experience to evaluate, the certainty may not be high, from which we can see that the device to assess the degree of rehabilitation is necessary. Next, we come to the methods and materials section. The principle on which my topic is based is the formula of surface force. Surface force is defined as the force acting on an internal or external surface element of the material. Surface forces can be divided into two mutually perpendicular components, the normal force and the shear force. A normal force acts normally on an area, and the shear force acts tangentially on an area, which is the formula that I'm showing on the video. F equals P and multiply with A, where the F letter is the force, P is the pressure, and finally A is the area over which the pressure is applied. From that principle, so I use film force sensor that called FSR402. The FSR 402 sensor is utilized in control and robot applications such as pressing buttons, measuring clamping force on robots, detecting pressure at one point, and so forth through the prediction of upper impedance changes. The sensor only has two connections, is highly stable, and is straightforward to use. Besides that, I also use an ergonomic design language makes the model fit in the hand. So I use the elastic rubber gloves with good elasticity. Now let's talk about the design part. These are the main function blocks of the circuit. We have the power block, include a 5V DC power with booster circuit that provides stable voltage and current for the whole model. Next is the sensor read block. Convert current into voltage to be input into the processing analog block. And finally is an analog block which connected to the Arduino board, multi-sensor signal with multi-analog ports. And this is how it works. When we start measuring, we will hold an object in accordance with the previously studied parameters. The force sensor will read the value, and the analog signal will be transformed to a digital signal via the Arduino Nano board. Report the user's finger muscle strength by displaying the value on the screen. And this is the circuit board I drew on EasyEater, the website I learned about in class. Following that, I 3D printed a box housing the circuit board, booster circuit, screen, and other components such as the switch and battery. As a result, the first prototype was developed. After many tests, my model has obtained acceptable data. According to statistics from the data and the documents I can refer to, the muscle force in the fingers will vary depending on the diameter of the object and the material structure of the object. As we can see, when the user holds an object with a diameter of 45 mm, the middle finger will have a force up to 120 Newton. In contrast, the little finger is only under 25 Newton. Besides that, with the index and ring fingers, both have complete opposites when the objects change size from 45 mm to 80 mm. It shows that the force in the index finger is stronger and will weaken when holding the larger objects, and vice versa compared to the ring fingers. The user or patient uses this measuring device and discovers that the force in their hands is too weak or insufficient in the comparison to a normal person. The device will warning them and provide them with the support methods. And that is the entire process of studying, creating, designing, and improving the product called Model for Measuring and Training Muscle Tone of the Hand. The above model's findings still contain numerous inaccuracies owing to the effect of other sensors during measuring. We will continue to explore and improve in the future to minimize the impact of the other sensor and reduce inaccuracy. We strictly follow to the Ho Chi Minh City University of Technology and Vietnam National University of Ho Chi Minh City's experiment and publication rules. Fully adhere to the experiment and publication guidelines of Ho Chi Minh City University of Technology and Vietnam National University of Ho Chi Minh City. Thank you for taking time to listen. Thank you.